Lines and Angles, Class 9, Exercise 6.2 NCRT, question number 5. In figure 6.32, if AB is parallel to CD, angle ABQ is equal to 50 degrees and angle PRT is equal to 127 degrees, find X and Y. Now you see in this question, it is given that AB is parallel to CD. This and this both are parallel. AB is parallel to CD. And this angle is X, this is Y, and this is 127. You have to find out the values of X and Y. So first of all, you see here, point number 1, angle APQ is equal to angle PQR. Reason, these are alternate interior angles are equal, because this line and this line both are parallel, so pair of alternate interior angles will be equal. So angle APQ is equal to 50 degrees and PQR is equal to X degrees. So X is equal to 50 degrees. First part done. Now again you see X plus Y is equal to 127. X plus Y is equal to 127 degrees, because exterior angle is equal to the sum of two opposite interior angles. This is the property of the triangles. If there is a triangle, this is the exterior angle, so this exterior angle is equal to the sum of these two interior angles. So X plus Y is equal to 127, and we already know the value of X, that is 50 degrees, plus Y, that is equal to 127 degree. So Y is equal to 127 minus 50, that is equal to 77 degrees. So Y is equal to 77 degrees. Answer, X is equal to 50 and Y is equal to 77. The reason you can write here, exterior angle is equal to the sum of opposite interior angles. Opposite interior angles. Okay. Now here question number 6, you see. Question number 6 says, in figure PQ and RS are two mirrors placed parallel to each other. An incident ray AB strikes the mirror PQ at B, and reflected ray moves along the path BC and strikes the mirror RS at C, and again reflects back along CD. Prove that AB is parallel to CD. Here you see, this is a plane mirror, this is a plane mirror, and these two plane mirrors are kept parallel to each other. They are parallel to each other. Now a ray of light is falling on this plane mirror, that is AB, and after falling at B it gets reflected at C. From C it is reflected to D. So this is the ray, it falls and passes here, BC reflection, the reflected ray from the surface PQ, and then it goes here, falls here at C and gets reflected at D. Now you have to prove that AB and CD both are parallel. So you see, you extend this, draw perpendicular at point B and C. Construction. So here the construction is, draw perpendicular at B and C as Bx and Cy. So here you see this is Bx and this is Cy. Now we know very well by the principle of reflection that when a ray falls on a plane mirror, then it is reflected back and it obeys the laws of reflection. The law of reflection is that if there is a plane mirror, the ray is falling and is reflected back. This is the normal ray. So angle of incidence is equal to angle of reflection. This you have studied in physics, law of reflection. So using the same property here, you see this is the Bx and Cy are the normals. Bx and Cy are the normals. This one and this one are the normals. So these are the normals. And if they are the normals, then this angle and this angle shall be equal. So similarly, this angle and this angle shall be equal. Let this angle be small a. So this is also small a by the law of reflection. If this is b, then this is also b. So if this angle is a, by the law of reflection, this is also a. Angle of incidence is equal to angle of reflection. If this is b, this is also b by the law of reflection. Now, Bx is perpendicular to the surface here, PQ. Bx is perpendicular to the surface here, and Cy is perpendicular to the surface here, and both these surfaces are parallel. So see, PQ is parallel to RS given. This given PQ is parallel to RS. Now Bx is perpendicular to PQ and Cy is perpendicular to RS. So this is perpendicular to this and this perpendicular to this. Now therefore Bx is parallel to Cy. Reason, write down. Two lines that are both perpendicular to two parallel lines are parallel to each other. Two lines that are both perpendicular to two parallel lines are parallel to each other. So if there are two parallel lines, you see this is perpendicular here, this is perpendicular here. So these two lines, if they are perpendicular to two parallel lines, they are also parallel to each other. Using this property, two lines that are both perpendicular to two parallel lines are parallel to each other. Using this property, you see Bx is parallel to Cy. And if Bx is parallel to Cy, so you see angle A and angle B are alternate angles. BC is transversal. Therefore, angle A is equal to angle B. This angle and this angle, their measurements will be equal. This implies 2A is equal to 2B. So angle 2A is equal to 2B. What is this angle 2A? That is ABC. Angle ABC is equal to 2B is equal to what? Angle BCD. So this angle and this angle both are equal. And which type of angles are they? These are also alternate angles. Since pair of alternate interior angles are equal, therefore lines are parallel. So what do you conclude? That AB is parallel to, this implies AB is parallel to CD. Hence proved. See once again here, there is a ray here AB falling on the mirror, and it falls and gets reflected here. Again it falls on this mirror RS and gets reflected. Mirror PQ is parallel to mirror RS, and so by construction we draw BX and CY both perpendicular to the mirrors, and you see this angle and this angle by law of reflection will be equal. This angle and this angle will be equal by law of reflection. So these are AA and this will be let it be BB. So you see PQ is parallel to RS, that is given. BX is perpendicular to PQ and CY is perpendicular to RX. So BX is parallel to CY because the two lines which are both parallel to which are both perpendicular to two parallel lines are parallel to each other. Therefore BC is a transversal. You see BC is a transversal. So angle A is equal to angle B. This angle and this angle are equal. This line and this line will be parallel. So you see they are parallel. So this angle A is equal to angle B. Angle A is equal to angle B. Multiply both sides by 2. 2A is equal to 2B. What is 2A? 2A is equal to ABC. That is ABC here. And 2B is equal to angle BCD. BCD. So these are alternate angles. You see these are alternate angles. And since alternate angles are equal, so lines should be parallel. Therefore AB is parallel to CD. Angle sum property of triangle. The angle sum property of a triangle means that the sum of all the angles of a triangle is 180. To prove this, let us consider a triangle ABC. ABC. Here you have to prove that the sum of angles A plus B plus C is equal to 180. So given triangle ABC, to prove angle A plus angle B plus angle C is equal to 180 degrees. Construction: draw CD perpendicular to CD parallel to BA and extend BC. So here you see we are drawing a line parallel to BA passing to C, that is this. We are drawing and extending this. We are extending this also. So you see this line and this line both are parallel. They are parallel. Now you have to prove here that the sum of angles A plus B plus C is equal to 180. So given a triangle ABC with angles A, B and C, to prove angle A plus angle B plus angle C is 180, construction: draw CD parallel to BA and extend BC. Now proof part. You see AB is parallel to BA, you can say BA is parallel to C. Why? By construction. So you see, if these two lines are parallel, so this angle shall be equal to this angle. You can take this as E, this is CD and this as E. So you see BA is parallel to CD, therefore angle ABC is equal to angle DCE. Why? Because these are corresponding angles. Corresponding angles are equal. So angle ABC is equal to angle DC. That means these two angles are equal. Now you see angle BAC. It means this angle. is equal to this angle is equal to ACD. Alternate interior angles are equal. So you see this angle is equal to this angle and this angle is equal to this angle. Now you see, and third thing you see, angle ACB is equal to angle ACB, same angle. Same angle. This is the same angle, common angle to this triangle also and on this line also. So here you see adding all three, first and second and third, all three you add. So you will get angle ABC plus angle ABC plus angle BAC plus angle ACB is equal to angle DCE plus angle ACD plus angle ACB. Now you see DCE means what? DCE means this angle. ACD means what? This angle. And ACB means what? This angle. This means this plus this plus this. All these three angles when they are added, so it gives you a straight line. It is a straight line, so it gives you 180 degrees. So this is equal to 180 degrees because linear pair property, linear pair axiom we call it, axiom. That means all the angles that are formed on a straight line, their sum is equal to 180 degrees. So you come to conclusion that angle ABC plus BAC plus angle ACB, that is equal to 180 degrees. This property is called as sum angle property of triangle. Sum angle property of triangle. So you see here, once again you see this angle is equal to this angle, corresponding angles, this angle is equal to this angle, alternate angle, this is the common one. You add this plus this plus this is equal to this angle plus this angle plus this angle, and the sum of all the three angles of a triangle is equal to the sum of all the angles that are formed on a straight line. All the angles that are formed on a straight line, their sum is 180. So angle ABC plus BAC plus ACB is equal to 180 degrees. Okay.